Hi everyone to this demo titled AI-XAI-LLM-enabled Trustworthy 6G Zero-Touch Network and Service Management. The main objective here is to enable trustworthy 6G ZSM using a novel pipeline composed of artificial intelligence, explainable AI, and large language models. The zero-touch network and service management concept enables autonomous network management without any human intervention. This includes detecting anomalies, identifying the root causes of anomalies, and resolving these anomalies autonomously. In this context, AI methods have been widely used in research to detect anomalies. However, one major drawback of these methods is that they are often black boxes, which lacks explainability. This makes it difficult to extract the root cause of the anomaly. To tackle this problem, XAI methods have emerged to explain AI decisions, thus identifying the root causes of anomalies. However, these methods often rely on complex numerical values to explain these anomalies, which can be difficult to understand for users with little domain knowledge. These users will not trust these ZSM systems. Therefore, natural language-based explanations are the simplest form so that all the users can understand. In this demo, we leverage large language models to generate human-friendly explanations to the users to enable trust in ZSM. In addition, LLMs excel at reasoning tasks, making them very powerful candidates for anomaly resolution. This aspect, which means decision-making with LLMs, needs to be explored in research, thus this is the second objective of this demo. The global architecture of the framework is illustrated in this figure. As you can see on the bottom, we have the infrastructure that will host the 6G services. On top of it, we have the network management system that will monitor this infrastructure to provide KPIs to the pipeline AI, XAI, and LLM to detect and resolve the anomalies autonomously. The LLM will generate human-friendly explanations to the users, and if ZSM is enabled, it will update the configurations autonomously to the infrastructure. In this work, we tackle this dynamic scaling use case where we have a microservice application running in the infrastructure. We employ XGBoost as the AI model to detect or predict the SLA latency violations within this application. We use SHAP as XAI to explain the XGBoost predictions. Also, we use Llama 2 as the LLM to generate human-friendly explanations and update the configuration. For this latter, we have two different tasks. The first one is to generate the E outputs, which is a reasoning task, and subsequently using this E output to extract the new configuration and generate the D output. This is a named entity recognition task. The demonstration setup is illustrated in this figure. As you can see, we have used two machines, one machine for the Llama 2 LLM, which is equipped with one A100 NVIDIA GPU with 40 gigabits of video RAM. The second one is managed by Kubernetes. This machine hosts the microservice application named here Go Server. Alongside this application, we have the XAI Autoscaler that is responsible for scaling the resources, CPU, and RAM of the Go Server. So this component hosts the AI and XAI modules and requests the LLM to get the new configuration in CPU and RAM. In the demo, we generated a load of HTTP requests using a tool named Apache Benchmark, and we monitored the CPU and RAM usage throughout time of the Go server application. So we used Prometheus as our monitoring system and Grafana that provides a user-friendly interface that allows us to visualize the CPU and RAM usage and limits throughout time. We also monitored the Llama 2 generated responses E outputs as illustrated in the top of the figure. These are the demo services namespace. We have the Go server, which is the microservice application, and the XAI Autoscaler component that is responsible to updating CPU and RAM resources of the Go server. We are showing here the logs of the XAI Autoscaler. And in this part, we have the logs of the LLM. We use this Llama 2 version LLM instructs. And these are the logs of the northbound interface of the LLM. As you can see, we have two tasks: explain to generate the E output and update to generate the D output. As stated before, we are monitoring the CPU and RAM usage of this microservice application using this Grafana dashboard. On the left, we have the CPU usage and limits, and on the right, the RAM usage and limits. The initial allocation is 0.25 CPU and 256 megabits of RAM. Now, we launch this component based on Apache benchmark to generate the load of HTTP requests to the microservice application. Here, the XAI autoscaler component is monitoring the CPU and RAM of the Go server application, and based on these KPIs, it is predicting whether it will be violating the SLA latency or not. So 1 for no and 0 for yes, it will violate the SLA latency. At this step, the autoscaler printed the SHA values of CPU and RAM as it predicted the SLA latency violation. This is the output from the LLM, and as you can see in the NBI, it requested the LLM to generate the explanation text using these prompts. Then the autoscaler requested the LLM again to generate this configuration, extract this configuration from the explanation text using this update endpoints. And this is done using this prompt. After that, it updated the resources of the microservice application. We illustrate this update here in this Grafana dashboard. As you can see in this dashboard, the framework predicted well this high CPU and RAM usage and avoided the SLA latency violation. At this timestamp, we have another updates, but only for the CPU resources. If we check the logs of the XAI autoscaler, we can see that the AI predicted violating the SLA latency, and the explanation text mentioned only the CPU will be updated based on the SHAP values. To this end, the autoscaler requested again the NBI of the LLM to generate the explanation text and then generate this update text. Again, from this point of view, we can clearly see that the framework made good decisions in updating the CPU and RAM resources. Thank you for your attention.